With covariance, we're ready to define correlation, which is probably something you have heard about before. So covariance itself, if you remember what the expression is, it actually depends on the magnitude of x and y. So x and y can be vastly different from each other. So we might want to have a measure of association that is not affected by any changes in the scales. And that's why people will go to something what we call a correlation, which is a measure of linear association between two random variables. We use rho and then x and y to denote the correlation, and it's defined to be the covariance divided by the product of the square root of the variance of x times variance of y. A few things here. The correlation is always bounded below by -1 and bounded above by +1. The magnitude of rho, which is the absolute value, measures the strength of the linear association. The closer the absolute value is to 1, the stronger the association, and the closer it is to 0, the weaker the association. The sign of these rho determines if it's a positive or negative relationship. And as you can see, because the denominator is always non-negative, so the sign of rho depends on the sign of the covariance. Okay. And lastly, if x and y, the rho between those two, is 0, then x and y are said to be uncorrelated. And keep in mind, we're talking about uncorrelated, not talking about anything about independent. Okay, independent means something else.